Today we are going to learn about AI-powered autonomous vehicle navigation. We will explore how AI enhances autonomous vehicle navigation systems for safety and efficiency, gaining insights into the technologies that enable precise vehicle navigation.
Welcome to this introduction on AI-powered autonomous vehicle navigation. Autonomous vehicles, or self-driving cars, are transforming how we perceive personal and commercial transportation. At the forefront of this revolution is artificial intelligence, AI, which enhances the navigation systems of these vehicles, ensuring both safety and efficiency. Today, we will explore the various AI technologies that make precise and reliable vehicle navigation possible. Whether it's for personal use or commercial applications, autonomous vehicles promise a future where transportation is not just convenient but also smarter and safer. Let's embark on this journey to understand the vital role of AI in this innovative field. Artificial intelligence serves as the brain of autonomous vehicles. It integrates numerous technologies to enable these vehicles to perceive their environment, make informed decisions, and execute actions. The core components of AI technology in autonomous vehicles include machine learning, neural networks, and computer vision. These technologies allow the vehicle to process vast amounts of data from its surroundings, such as road conditions, traffic signals, and pedestrian movements, to navigate safely and efficiently. AI systems in autonomous vehicles are designed to mimic human cognitive functions, enabling the vehicle to react and adapt to dynamic road situations in real time. This integration of AI not only enhances vehicle autonomy but also improves safety, as AI systems can process and respond to information faster than human drivers. Real-world applications of AI in autonomous vehicles include ride-sharing services, delivery robots, and long-haul trucking, all of which are gradually redefining transportation and logistics. Machine learning plays a pivotal role in the navigation systems of autonomous vehicles. It involves training algorithms to learn from data, which improves the vehicle's ability to navigate complex environments with precision. Machine learning enables the vehicle to recognize patterns in the data collected from various sensors, such as cameras, radar, and LiDAR. This capability is crucial for predictive navigation, where the vehicle anticipates and responds to potential obstacles or changes in the driving environment. By continuously learning from new data, machine learning algorithms help autonomous vehicles improve their navigation accuracy over time. These algorithms handle complex scenarios, such as merging onto highways, navigating through intersections, and adjusting to different weather conditions. The adaptability of machine learning systems ensures that autonomous vehicles can operate safely and efficiently in diverse environments, making them a cornerstone of AI-powered navigation.
Sensor technologies are critical to the functioning of autonomous vehicles, providing the necessary data for navigation and decision-making. These vehicles are equipped with a variety of sensors, such as cameras, radar, LiDAR, and ultrasonic sensors, each serving a specific purpose. Cameras capture images of the vehicle's surroundings, radar provides information on object speed and distance, LiDAR offers precise 3D mapping, and ultrasonic sensors assist with close-range detection. Data fusion techniques are employed to combine the data from these sensors, creating a comprehensive understanding of the environment. This fusion enhances situational awareness, allowing the vehicle to identify and interpret obstacles, road signs, and lane markings accurately. Real-time data processing is essential for autonomous vehicles to respond promptly to changing conditions, ensuring a safe and smooth driving experience. By improving vehicle perception, sensor technologies and data fusion play a vital role in the effectiveness of AI-powered navigation systems.
Real-time obstacle detection and avoidance are essential for the safe operation of autonomous vehicles. The ability to detect and respond to obstacles, such as pedestrians, other vehicles, and road debris, is crucial for preventing collisions and ensuring passenger safety. Various technologies are employed for obstacle detection, including computer vision, radar, and LiDAR. These technologies work together to provide a detailed view of the vehicle's surroundings. AI algorithms analyze this data to identify potential obstacles and determine the best course of action to avoid them. The role of AI in obstacle avoidance is to process information quickly and make split-second decisions that a human driver might struggle with. This capability is particularly important in complex or unpredictable environments, such as busy urban streets or highways. Despite the advancements in technology, challenges remain, such as accurately detecting small or partially obscured objects. Ongoing research and development are addressing these challenges, aiming to improve the reliability and safety of real-time obstacle detection and avoidance systems in autonomous vehicles. Path planning is a crucial aspect of autonomous vehicle navigation, involving the calculation of optimal routes from one location to another. Path planning algorithms are responsible for defining these routes, taking into consideration factors such as road conditions, traffic congestion, and potential obstacles. AI plays a significant role in path planning by enabling the vehicle to make dynamic adjustments to its route based on real-time data. This adaptability is key to balancing efficiency and safety, ensuring that the vehicle reaches its destination promptly while avoiding hazards. Path planning algorithms must also handle various environmental variables, such as weather conditions and road closures, which can affect the chosen route. By continuously analyzing data from sensors and external sources, AI-powered path planning systems optimize the vehicle's navigation, making them indispensable for autonomous driving. These systems are designed to ensure that autonomous vehicles can travel safely and efficiently in diverse conditions, contributing to the broader goal of making self-driving technology a viable and reliable option for transportation. Safety is a paramount concern in the development and deployment of autonomous vehicles. Ensuring the safety of passengers, pedestrians, and other road users is essential for the widespread adoption of self-driving technology. Regulatory frameworks have been established to set safety standards and guidelines for autonomous vehicles. These frameworks are designed to ensure that vehicles meet specific safety criteria before they can operate on public roads. AI plays a critical role in compliance with these regulations, as it enables vehicles to monitor and adhere to safety protocols. However, challenges in standardization remain, as different regions may have varying regulatory requirements. Addressing these challenges is essential for achieving a consistent and reliable level of safety across different markets. Public trust and acceptance are also crucial, as the success of autonomous vehicles depends on their acceptance by consumers. Building trust involves demonstrating the safety and reliability of AI-powered navigation systems, as well as addressing concerns related to data privacy and security. As the technology continues to evolve, ongoing collaboration between developers, regulators, and stakeholders is necessary to ensure that safety and regulatory considerations are adequately addressed. Despite the advancements in autonomous vehicle technology, several limitations and challenges remain. Technical limitations, such as sensor accuracy and data processing capabilities, can affect the performance of AI-powered navigation systems. Environmental challenges, such as adverse weather conditions and varying road infrastructure, also pose significant obstacles. AI's adaptability is crucial for overcoming these challenges, as it allows autonomous vehicles to respond to diverse conditions and scenarios. However, ethical considerations, such as decision-making in complex situations where harm may be unavoidable, add another layer of complexity to the development of autonomous vehicles. Addressing these ethical dilemmas is essential for ensuring that AI systems make decisions that align with societal values. Overcoming these obstacles requires ongoing research and innovation, as well as collaboration between industry leaders, researchers, and policymakers. By addressing the current limitations and challenges, the autonomous vehicle industry can continue to advance toward a future where self-driving technology is safe, reliable, and widely accessible. The future of autonomous navigation holds exciting possibilities, driven by advancements in AI technology innovation. As AI continues to evolve, autonomous vehicles are expected to become more capable, reliable, and efficient. Future developments may include enhanced machine learning algorithms, improved sensor technologies, and more sophisticated data processing capabilities. The integration of autonomous vehicles with smart city infrastructure could revolutionize urban transportation, leading to more efficient traffic management, reduced congestion, and lower emissions. The potential for innovation extends beyond personal transportation, with applications in public transit, logistics, and emergency services. The impact of autonomous navigation on transportation could be transformative, offering greater accessibility, convenience, and sustainability. As we look to the future, the vision for autonomous vehicles is one where they seamlessly integrate into our daily lives, providing a safer, more efficient, and environmentally friendly mode of transportation. Achieving this vision will require continued collaboration and investment in technology, infrastructure, and regulatory frameworks, paving the way for a future where autonomous navigation is a reality.
In conclusion, AI-powered autonomous vehicle navigation is a rapidly evolving field with the potential to revolutionize transportation. We have explored the critical role of AI in enhancing navigation systems, ensuring safety, and improving efficiency. While there are still challenges to overcome, such as technical limitations and regulatory considerations, the potential for growth and innovation is immense. As we move forward, continued investment in research, development, and collaboration among stakeholders will be essential to achieving a future where autonomous vehicles are a safe, reliable, and integral part of our transportation system. Thank you for joining us on this journey into the future of AI-powered autonomous vehicle navigation.